Hello good people, welcome and welcome back to my channel. Let us continue with our cooking island. Today we are going to talk about the burners for the griddle. It's an H burner. That's what we are going to design, and each griddle will be carrying two burners. Okay, so let us open the grooved griddle. I have it, I think. Yeah, here it is. Yeah, the burners will be right around here. You will see about it when we start our assembly. Okay, so without much ado, I will close the range, because I don't need it. Right now, what I will be needing is the griddle. And remember, this griddle, they are of the same size. Let us remind ourselves the size of the griddle. I think it's about 500 or 499. Yeah, that is 500 by, I think from there to here should be 464. So we are going to make a burner of the length of the burner will be 400. So you can go to new file and do a new part. Just for a reminder, my people, my custom units are mmgs and everything else, right? So I will go to the front plane and create new sketch, and I will do a circle from the origin, and the burner will be of dia 25 tube, dia 25, and like we have said, the length will be 400. So extrude and extrude it from the mid plane. Length is 400. That's okay. Now this is a tube, so we will make it hollow, then we will close it. You know, you have to put some end caps there, and and do full welding. Don't want your gas to escape. Thickness is 1.2 millimeter. That's okay. Now there we go. Now let us do the holes for the burner. So I chose top plane and started a new sketch. The new sketch, I do center line from the origin. This will assist us in mirroring our holes. We do a circle. The diameter of the hole, this should be as small as possible, so that you need pressure. Remember, these burners are supposed to be high pressure, and this should be 5 millimeter, and from this edge it should be this edge to this should be 5 millimeter. I think that's okay. Then if I could select this and mirror about the center line. Yeah, I feel like that's okay. Then we go to feature, extruded cut in the opposite direction. You need to just up to, is it surface or through hole? Yeah, through through hole. Through hole will do. Let us look at the orientation of the. We go to the top plane. Yes, this is okay. You don't want the holes to be, you know, how do I put it? The holes are okay, okay? I don't have the right English to explain that. Now, if you could go and choose linear pattern and choose the face, and what to be patterned is the extrude cut holes, and you want them to go all the way up to the end of the tube. Yes, there. Those are 40 holes. That's good. That's how your banner will be looking like. Now choose the right plane there and start new sketch. Because it's an H banner, you need to have a circle from the origin there, and the diameter is, you can do a hole of 10 millimeter. 10 millimeter. This would be like the inlet of this side of the banner, and extrude cut in the opposite direction. You cut through all. Yeah, there you are. You have your hole. Now if I choose this face here and start a new sketch, then I convert entity. I choose the outer line there, the outer edge, and then I extrude 1.5, around 1.5 millimeter. Yeah, that's just a cap that we will do full welding, because you need, you know, today my SolidWorks is thinking too much. Yes, the gas is supposed to be exiting from the holes only. So this one, you close here and do full welding, no leakage. So go to front plane and choose mirror. And what you're supposed to mirror is that new extrude bosch, so that the other side may also be closed. Okay, that is good. Now, before I finish with this, let me go to top plane and start a new sketch and hit normal. What I want to do is create a bracket that will be for mounting the banner to the griddle. I choose this line and this edge and make them collinear. Yeah, then I smart dimension from here to the outer edge. You can make it 15 or 10 millimeter. There's no harm. Just don't take it very far from the don't take it too much to the edge. You can do 25. Yes, 25 I think will be good. And the size here, you can make it a plate of 30 by 30. I think that plate is okay. Now create a circle, and this should be, because we are going to use roofing bolt M10, so you can create a bolt of a hole of 11 millimeter and should be at the center of the plate. This should be 15 mil, and from here to here should be 15. That's about that. Now let us mirror that to the other side. Create center line. Well, you can finish with that, or you can mirror it at this point. So choose all that and mirror about the center line. There you go. Then go to feature and extrude. Here extrude through the mid plane and make it, use a plate of 3mm. 3mm would be good. That's good. That's how our banner it's starting to take shape. So go ahead, save this one. We will save it from Griddle. Here you can create a new folder and call it banner. Then you open the folder and save it as part number 1. Just long banner. Don't know which. You can use whatever name that you want. That's okay. Now remember, this will be a H banner, so we want to create this part that will be joining the long banners. Okay, so let us go to new part. Okay, then we go for the right plane. Don't know what is not happening. This thing of mine keeps misbehaving. Yeah, so create a circle, the center, same dimension, that is 25mm. And between this and this should be, let us first make these circles concentric. Looks like I didn't choose the center when I was doing the other one. I didn't choose the origin, but now they are good. This is 1.2. Yes, that's okay. I keep telling you there are different ways of doing the same thing. Like the first one, I extruded blind and I did do some shelling. This time round I have just decided to make a pipe out of it. The size is 100mm. I hope you have seen that. Don't get carried away by my too much talking. Go for the front plane and start a new sketch. Make it normal. We want to notch this pipe. I hope you know how, when you intend to join pipes, how to do the notching. Okay, so actually we can do both sides instead of mirroring. That should be okay. See, they are from the center of the tube. Then extrude and cut, cut through both. Yeah, that's our pipe has been notched. So when we will join it to the other pipe, it will fit correctly and the welding will be good. Be no leakage. Go to the top and create new sketch. Did we choose new sketch? Top sketch. What's not happening here? Top plane, new sketch. Yeah, we are at new sketch. Make it normal. Here you want to create the holes. Same size, 3mm, and from here to here you can make it 5mm. Yeah, that's okay. Then choose the center and the origin, make them horizontal relationship. I don't know what's going on with my... I think it's the mouse. Extrude the cut and cut just one side, the opposite, at the top there. That's good. Then you linear pattern, choose that face to be patterned. Should be that hole that you've made there, and this should be about 10 of them, but I think actually you can do 5. You don't need to do that spacing. This spacing is, yeah, 20 mil is good. The purpose of this is to spread the fire from one burner to the other one. Is that correct English? I think that should be it. You don't put so many holes here, you just need a few. So 5 holes are good. That's okay. Now go back to top plane again and start a new sketch. From the origin, create a circle, dia 10 millimeter, just like the other one. This is 10 mil, and extrude a cut on the lower part. Feature, extruded cut, yes, like that. That's good. The hole is there. The hole is there. So this is good. Go ahead and save it as short burner tube. Part number 2, short burner tube. You don't have to write tube. Anyway, you know better. Go to new file and create part. Yes, we need to do what? To go for the right plane and create sketch. New sketch. It's not coming. Right sketch. Good. Now select line from the origin there, like this, like this. Okay, smart dimension, this make it 30 or 35. 35, and this make it 250. The degree here can make it right around 100 degrees. That is okay. Now fillet this and fillet it to 12.5. Actually this should be more of an elbow, or if you have a tube and you can bend it with these parameters, then you are good. Yeah, sketch 1, exit sketch. How do I exit sketch? Man, my I'm wondering what happened to the icon of exit in sketch. Then go to the top plane and start a new sketch here. and this, create a circle, the center that is from the origin, and the diameter of the circle is 25, because we want to sweep this on the first sketch. Still, it's not giving me the option of exiting. What happened to that menu of exiting sketch? I don't know. Feature, go to sweep, and the sweep profile is sketch number 2, and the circular profile, there you go. Yes, now we have our banner. Come in, shell this 1.2 millimeter, and choose this face and choose this face because you want it very hollow. There you go. Now go to top plane and start a new sketch. Yes, make it normal. We want to create a rectangle, a slot here, like that, for the purposes of setting the aeration gap. Yeah, what am I saying? Am I making any sense? We are trying to dimension from here to here. I want to start smart dimension from okay, let me create a center line. Fine, that relationship is good, so I want to smart dimension from this to this. Make it 20 mil is good. And you shouldn't have done that, eh? Yeah, that's good. Then this, I'll make it 12.5. Let's see. Yeah, that's what I wanted. Now I will go to feature and extruded cut, and this I will choose up to next. Yes, because I just want to cut that one. Before I do that, let me continue with the sketch first and create I create a circle. The diameter of the circle should be right around 9 millimeter, because we'll use M10. Yes, let us do 10.5 mil. That's good. From the center of the circle, it can be around 10 millimeter. This is for the bolt that will be for the adjusting that. And how do I explain these things? You hold on, you're going to see. Up to next, or up to surface. Is it up to surface or up to next? up to next. Yes, that's good. Our banner is taking shape. So this part, okay, we go to right plane again and create new sketch. Normal, create a circle. We want to notch also this part. That's about that. Extrude a cut through both. Click OK. Go ahead and save this part as part number 3. Sorry, 3. I don't know. We will call it what? We'll call it the inclined. Inclined tube. Yes. Now we need to create a small piece of tube that will go inside in this tube. That tube is the one which will be controlling this gap for the purposes of aeration. You remember the cooking gas, is it, what is the name of this liquid, you know, cooking gas? What do you normally call it? The LPG gas, right? Yeah, the LPG gas has, for combustion purposes, it has to mix with oxygen, right? But you have to control the oxygen for the purposes of having the best flame. Yeah, this, just like we were doing it in our O level secondary school, or I don't know how you call it there, wherever you are watching from. The Bunsen burner. The first lesson we learned in our lab was about the Bunsen burner and how to ensure you are having the correct flame, the bluish flame. And there was a hole there. There was a hole there where you were adjusting, you know, the aeration. That is the same case here. So let us create another part here, and just a small tube of dia 20. Remember, this is dia 25. This will be dia 20. Go for the front plane, create new sketch. I don't know what is not happening today. Diameter of this should be 20 mil. And the size of it, extrude mid plane, the size of it should be 20 or even 30. You can do that, even 15, there is no harm, right? You don't want it to be what do we call, too long or too short. Shall this 1.2 millimeter through hole. Yes, you know, this is not for blocking the gas, it is for the purposes of what do we call it, the purposes of regulating the air. Reference geometry here, and I create plane, and this plane it should be 10 millimeter on from the origin. Then from that plane I'll create new sketch. All I want to do is create, you know, a small handle and a stopper for the tube, so that it might not be getting lost in there in that tube. And you know, you can weld a small rod of 8 millimeter and very close to the edge, to the outer edge, like this. They are saying is 6mm. You can do it like 2mm from the edge. It shouldn't be 2 because the dia of this thing is 8mm. 8 plus 2, so 10 will be good. Is it? What is the diameter? 8. 2mm is good. So extrude feature. And the size should not be too big, like 30. Just for the purposes of having a handle. Even 20 would be good. Yes, like that. Hide this. Save this part as part number 4. Now what are we going to call it? We are going to call it we are going to call it what? Dia 20 tube. I have lacked a better name. You will see it when we start doing our assembly. Now at this point we are going to create jet back. Is it jet, flare nut, jet, and something like that? I wish I could just watch. So we create new part. Okay, and the first thing here we will create is the front plane. Start a new sketch there. Create a circle of diameter. This should be a solid of 5mm. 5mm. Dia. Extrude. Feature extrude. One direction. This is about 7mm. To create that nozzle. And jet, select this face. Okay, this is something that you can buy. You can, they are imported, right? I just want to show a representation of how it looks like. So you don't have to worry about it. It's just a representation. It might not be very accurate. Why am I doing this? This can be of dia 8mm, 7mm is okay. It's just a representation, so let it not worry you very much. And this can be 4mm. Yeah, from there we create new sketch. Normal. Choose the polygon, origin. That's okay. This, make it vertical. Choose this to this, make it 12 and extrude by 5mm. It's also good for your practice and for those guys who are very new at 4mm is still okay. At SolidWorks, it's good when you are doing some of these things for the practice purpose. Now I want to create a very small pinhole. Do you call it a pinhole? A small hole, because you need the gas should be at high pressure and you need it, you need a very tiny hole like this. It might look big from the sketch, but a 3mm hole is very small. Yeah, so extruded, cut and cut through hole. And remember, this part is very airtight. It should have no leakage whatsoever. So I'm going to select this face and create the washer nut that will be welded to the tube. Our tube is diameter 25, so this can be 35 millimeter, 35 millimeter. That mil would be good. 30 mil, and it's extrude it. This 2 millimeter is okay. Then select this face, start new sketch, another back nut, select polygon from the origin. That's okay. Create normal, make this horizontal. Is it horizontal or vertical? Then choose from here to here, you make it 12 millimeter again. Yeah, I think it's same size as the other one, and extrude these 3 millimeter. Is it 3 or 4? 5. Yeah. The purpose of this is because here now we have the female. Is it the male or the male part of the flare nut? So here we create circle. The diameter of this circle should be around 8 millimeter. Then we extrude it 10 mil. That's okay. Create a chamfer. This should be 2 millimeter and 45 degree. You choose this edge. That's okay. Now remember our pinhole is going up to the washer, so we create a circle from the washer, and well, I don't know, you can make this a little bit bigger. There is no problem. Big is like 5 millimeter. Then extrude the cut through hole. I don't know, that diameter is big. No, it's good. Yeah, so our hole is going through. Now I don't know whether the others I was choosing material. This is always copper, metal, copper. What kind of copper? Polished copper, brushed copper. Yeah, it's always copper. Now go to hole wizard. Where is hole wizard? And choose thread, and your thread will be starting from here. Yes, if you want to offset, you can offset by 1 millimeter. No, don't offset. And your hole up to here, and it's metric die. Is it metric die or metric tab? Metric die, and you choose M10 by 1 or M10 by 1.5. I don't know about threads very much. Like I was telling you, these are things that I don't worry about myself. Yeah, I should have offset the other one so that I may have a better finish. Can I offset it by 5? Yes. Yes, see, the threads are good. The threads are better there. So I will the purposes of making it better, I choose this face, start a new sketch, then convert entities and choose the face. Has the entity been converted? I hope so. Then extrude. Yes. And this I will cut through all. And the end of the thread will be good. Yeah. So this part is the one which you normally connect to the flare nuts and all that. The gas people know better. So that is that. Save it as nozzle and jet. Part number 5. Nozzle and jet. Yes, can we start our assembly and see how our banner will look like? File a new assembly. Click OK. And the first part is banner. Actually, can we bring everything, because we will be requiring everything apart from the griddle. Yeah, so that is 1, 2, 3, 4, 5. Okay, now we want to do our assembly, and unfortunately I will be having the same issues I was having last time of you know, if I choose that plane and this plane for the short one and make them coincident. Then I will choose met. I will choose this, make it tangent to this. Okay, now see here, you will do your full welding. Remember the hole that is there, like I was telling you, gas will be coming from the pinhole here through this tube, through this hole, then it can go to this side or the other side. When we mirror this, we will see. Yeah, so that is that. Now I'll choose again to met, and I will take which plane? Yes, this right plane, and I will choose the inclined tube right plane. Inclined tube right plane. Yes, then I will met again. I don't know whether this will work. Tangent this and this. When I choose top lane and met with the top plane of the inclined tube. No. That I shouldn't have done. Before I go to that, let me choose this top plane and of the long banner. Yes, and to make them coincident, I met with Is this floating or fixed? It is fixed. So I don't know. Yeah, now looks like it is good. It is fixed. It is not moving. Let me see if I met the top plane and this other top plane also, whether it will do me right. That top plane and top plane of this, it's not coming. So there is something I need to delete there or edit. And go to the mates and edit something. Yeah, they are coming in as new folders. Will I remember which folder that was? This is good. Folder number 4. This, I hid it. I hid that mate, and I will clear this selection and make coincident. Therefore I take this top plane and the top plane of this. Yeah, now that is better. Then I will choose not the right plane but the front plane and mate it to the front plane of the small banner. That is front plane of inclined, front plane of the small banner. Yeah. Yes. Now the banner is looking good. There is where you're doing your welding and all that. Now I will take this insert, not mate, and make these two concentric, this and this. Concentric relationship. Like I was telling you, this tube, we are going to edit this. You want, okay, let me open this and add. I think I don't need this extruded push. It is not necessary, so let us delete. Follow also the sketch and delete. Well, these people, they normally know how to do it, you know. Assembly, sub-assembly. Yeah, like I was saying, this tube goes in there, and that is what you use to regulate this hole here, the kind of the amount of oxygen that you will be allowing to mix with the combustion, the cooking gas. Now we met this and to make them concentric relationship. This concentric to this. That's good. Then you met it again, and of course this face will be welded, tight welded to this face here. That's good. There you have it. Now what will you see if this tube comes to this, touches the washer, the amount of oxygen that will be going inside the tube is very small when you look at the space that is here. So what I was saying is, you adjust it, you open this opening or close it depending with the flame. This is normally done as your burner is on, as you know, observe how the flame is behaving. And if you're satisfied, there is a bolt that is normally, you weld a nut on this hole and a bolt, so you tighten the bolt tightens this tube this inner tube in its place. Yeah, we've done some little observation of how they do their gases, their gas fittings. I'm going for the inclined tube and choosing the right plane, and I will mirror components. Is there anything else that I have not inserted? I think we are good, and the component to be mirrored is this long banner. No, it shouldn't be like that. It should be like that, but no, I don't like that, because now the holes are on the other side. I don't know why it flipped. It shouldn't have flipped. Now they will be forcing me to insert another banner. Oh man, long banner. Then I do what? I rotate it on the okay. No worry. Met. And met. We are going to take this and this. They flash? Yes. Then again met. This and this. Alright. Then I don't know. Met. Now this will give us some trouble. Tangent. This to this. Perfect. Yes. Our banner should look like that. Our H banner should look like that. And like I was telling you, we will require two. Do I need to do a bolt and nut? There, yes. Let us do very quick bolt and nut. Now save this as banner. Griddle banner. That's so cool. Go to file, new, and we create part. Click OK. Go to the top. Start a new sketch from the top lane. Center. No, I should choose the polygon. We are doing the bolt, then we'll do the nut. This, make it vertical. The diameter from here to here, we are using a bolt of 10, so this should be 14, right? I don't have a bolt here that I can take the actual measurements, like I was telling you this, and just want to know how to draw it and to do some correct representation. Otherwise, we later will be doing bolts, nuts, the actual drawing of a bolt and a nut. No, the extruded bosh, we edit and make it in the mid plane. Yeah, mid plane. Yeah, that's good. And we choose this face here and start a new sketch, circle from the origin, and we select the circle and this edge here and make it tangent relationship. Then we will extruded cut, and here we will choose flip side to cut degree of 45, and end condition will keep through hole, right? I think that is okay. Yes. Then we'll choose our top plane what's going on. I can't see the top lane and the mirror component, and what we are mirroring is that extruded cut. That's good. Yes, our bolt is taking shape, so choose here, new sketch, center circle. We have said we are using M10 10 mil. I hope it is in proportion with the the bolt head, and this should be 2 inch or one and a half should be what, 25, 32.5, 25 plus 12.5, that equals to what, 37.5. yeah, bolt is there. We go to not fillet but chamfer. I don't know whether we keep the same parameters, 2 and 45 degrees. Yes, that's okay. Then we go for the hole wizard, choose thread. Our thread start from here. We can offset it. We can offset it by 2 mil. I don't know. And they are coming up to where selection up to here. Actually, we can offset it by 5 mil. 3 mil is okay. Metric die M10 by that. That's good. Will take some little time. Yeah, the thread is good. You need to finish this area. You give it a nice finish, create new sketch, and you choose this convert entities and choose this face, right click, then feature extruded cut through hole. That's good. Yes, our bolt is good, but I feel like the length of the bolt is not really pleasing, so let me edit this and make it 50 instead of not that one. I feel like the bolt this feel like it's not enough. That's why we are using the roofing bolt, right? Just because the height of the burner from the plate, you should have enough room. What am I saying? You should have enough length to adjust the height of the burner to the size that you want. I know. Hold on, we will do our bolt. But number 6, we will do our assembly to the Griddle, and we will see. It will make sense of the gibberish that I'm trying to tell you right now. Do we need a nut and a washer? Nut. Yeah, let us create nut. I'm not going to create a washer. Not create washer. Top sketch, new sketch. not you, but you there. I don't know why I keep making this vertical. This is 14. Yes. Then we extruded bush. We extrude it on the mid plane. And, 5 millimeter. Is that the thickness of the nut? Are they always that thick? Then we create sketch here, just like we did to the head of the screw of the bolt. Same thing applies here. Make this and this edge tangent, then extruded cut. Mid plane, through hole, not mid plane, should be through hole, flip side to cut, and degree 45. Good. Then go to the top plane and linear pattern, not linear but a mirror, and the component to be mirrored there. The feature to be mirrored is that. That's good. Choose then again the top, start new sketch, create the hole for the nut, M10. That's what we're looking for. 10. Extrude cut through hole. Hole wizard. Thread. From here up to this edge. And this should be metric tab, not metric metric tab, because do we need to offset it to give it a clean finish? Yes, we should have offsetted the threads. Edit feature. Offset, not that one, but offset here. Yeah. This other side, I don't know whether if we choose this and edit, I'm not sure, because how do we correct this thread? Are we supposed to Yes, it's only the direction that we needed to change. Yes, our nut is good. Save it. As part number 7, nut. Now let me choose material for the nut, and I can choose which nut. I'll choose iron for the purposes of differentiating, you know, when we are doing our assembly. Actually, I need to add the color. Can I give it an orange color? Yes. I don't think this should worry you very much, because we are just trying to make it look different. Now let me bring up a nut here. Insert nut. And I will make it concentric relationship with the hole. Like I was saying, that nut, you weld it permanently there, permanently on the surface of the tube. Okay, it's welded permanently there. Let us bring in again bolt. This bolt doesn't have to be this tall, you know, this long. English. It doesn't have to be this long, okay? You can do a 1 inch bolt, like I was saying. It's just for the purposes of, you know, once you do your adjustment, holding that inner tube in place. We make this concentric relationship. I choose this face, and I choose one of the faces of the, yeah, where is my thing? And there you go. So when you adjust your tube to the right size, to the right opening, you tighten the bolt. But remember, the inner tube, we didn't punch a hole. You don't want any leakage of the gas. We did not punch any hole, right? Yeah. So, and also the reason why we did 200 millimeter, actually, you might be forced, I don't know whether this degree, you might be forced to increase it. You don't want open flame near this opening, because there will always be some gas here, and it is always easy for the flame to have an unwanted flame here. That is why this thing is at an angle. I was telling you, the gibberish that I'm talking will kind of start making sense when we do the assembly. Feel me? So at an angle, you don't want open flame from here getting too close to here. You don't want any fire in your kitchen. Okay, our burner is good. Now we can go ahead and close anything that save documents, rebuild, save. We can go ahead and close what we don't want. We just want to be left with the burner, the griddle, and the bolt and nut. The incline tube we don't need. This we don't need. Jet we don't need. we need the burner nut and yeah. So we open the griddle and insert component, and the component to be inserted here is the griddle burner. Okay, now having said that, we start our assembly into mate. We can make this to be distance of 50 millimeter, something like that, from the edge of this to the outer edge of the griddle. We will see, yeah, 50 millimeter is okay. Again, you don't want your burner coming so close to the edge such that the flame will be, you know, I'm getting ahead of myself. I will explain that. And this should be 50 millimeter from this. Don't know whether 50 is sufficient to here. Yeah, 50 looks sufficient. Now leave it at that. Insert component, and component to insert here is bolt. Bolt is good. Mate, the head of the bolt is the one which is welded to the bottom of the plate, the hot plate. That head, you weld it here. Okay, then continue to mate and make the head, the bolt and the hole concentric relationship. Choose that, and this hole of the plate, make it concentric. Yes, that's good. Now your burner should, like I was saying, that bolt should be long enough for you to have, you can adjust it accordingly. You know, this gap, that bolt is the one which will give you room, because you don't want your burner so close to the plate and you don't want it very far away from the plate. Okay, that is the work of gas fitters and they know better, but ideally this is how you do it. Now we insert nut and we mate it, this face of the nut, because then this you do with 2 nuts after, and a washer. If you want, you can do a washer. That face should be on this side of the plate. Then you choose and make concentric relationship, concentric, that face, that, and the bolt, such that now I think this should be making sense. See, now you're okay. Let us first bring in another nut. Insert nut. We could have mirrored this. Mate. Now this face should be on the other face, on the other side of the bolt, the plate. Then you make it concentric with the bolt again. Did we choose concentric relationship? No. We need to choose concentric relationship, and that is this and this. You can even choose yes. So you see your burner is held in tightly in between those nuts, right? So you can adjust it up down. That is why I was saying this bolt has to be, the length has to be sufficient, for your flame. The other thing is, you don't want your burner more to the outer edge of the griddle, because if you bring your griddle, say this burner was like 30 millimeter, was the holes, you see these holes, if they were very close to this, and the flame will be is it protruding? The flame will you don't want any flame on this edge. You want flame at the bottom, at the plate, that's what I'm saying. Now let us and also, like I was saying, this bolt is not necessary, it should not necessarily be this tall, this long. Street language, man, that's why I'm calling it tall. It doesn't necessarily to be that long, and you can use a smaller bolt for the purpose of that. I have explained. If you allow me to choose, let me collapse everything and choose and go for this. Where is this? The shorter burner. I expand it and choose the right plane and mirror component, and the components to mirror here is bolt, nut and nut. Then click OK. Then I still could go for the which plane is that? The right, the front plane, and the mirror components, and the components to be mirrored here is the last mirror that I have just done. This is it, so I think so. Yes, see, our burner is perfectly sitting under the plate. Remember, this bolt head is welded to the plate, and since when you're doing your connection, the copper pipes and everything, you just need to tighten a flare nut here. And I was saying that your griddle is placed on the cooker, the cooking island, the range. It is not welded, it is not mounted by any bolt or anything. So when you want to do your servicing and you are removing the entire plate together with the burner, okay, then you do your servicing and take it back. And the burner, the beauty of the burner is that you can also remove the burner by unscrewing this bolt, this nut, leave the bolt intact, remove your burner, do whatever you want to do with your burner, and you are good. And like we were saying, this plate we need to have two burners. So if I may collapse also everything again, and I go for the grooved plate and choose the plate, I want the plate. I want to choose the plate. Where is the plate? Here's the plate. Grooved plate. Then I go for the right plane and I mirror component, and the component to be mirrored is this, I don't know. Then the burner, where is the burner? Let me collapse that. Griddle burner. Yes, there we are. Our burners are good and very much in place. So, and the reason why we don't do a one big hell burner, H-shaped burner, is that if you do this here and this and the outer one here, and probably one at the middle, and then you have another tube here, the plate will not be getting heated evenly. If you look at this, the burners, the spaces, this space, this space, this space, this space, and this space are almost equal. So the plate will be heated evenly. There will be an even distribution of heat on the plate, and when you're doing your cooking, like our chefs will tell us, they won't be having issues with what do we call it? You know, you're trying to do some barbecue, and one area I don't know. Let me leave that. I'm trying to open the island range, open range, SolidWorks layout, island cooker range. We see. Now you can't see the burners because they are under there on this plate. That is why I was telling you the burners will be guiding us on doing the openings. No, we don't necessarily need to have the burners in place for us to create openings for the tabs. We will do the openings for the tabs on this plate. Then we will do a manifold. You need to have a manifold for the connection of the gas on this side, for the connection to this nozzle and jets, and to the gas taps. And you also need to have an opening. We will do that in our next video. I don't know. No, in our later video. We will finish with all the components, then we will come to the gas fittings and how they are connected. From here, like I was saying, the griddles are high pressure, and here we have high pressure burners, 3 of them, and low pressure burners, 4 of them. So you will need a Lego someplace, and manifolds here and another manifold there. Okay, so that's it for today. I hope you have learned something as far as the burners are concerned, and whether you are doing gas fittings or whether you are doing generally fabrication and contracting people to do the gas fittings for you, it is always good to be aware what normally happens. There is no evil, there is no harm in having skills and knowledge. I have never seen anybody walking, at an angle or limping because they have too much knowledge of things. Knowledge doesn't make anybody tired. Knowledge doesn't hurt. It is good to know these things, whether you are contracting people to do them for you, or even maybe you can be doing it yourself. Okay? And probably you have been facing challenges, or you have been doing it differently from the way I'm doing it, and you want to, you can try something different. Maybe you will get a better results than how you have been doing it. I also keep telling you people, whoever thinks that they have a better way of doing anything, whether it's moving around SolidWorks commands, do comment in the comment section. I will follow the comment, or if you have a channel, share it with us. Let us get to enlighten one another as we increase knowledge day in, day out, because it doesn't hurt. It doesn't hurt to know different things and different ways of doing one thing. I sometimes feel like I did not do myself great justice when I had the time and the ability to learn how to do welding. I specifically decided not do to learn welding because I felt like it was hurting my eyes. But nowadays I'm paying the price because when I want to do a small welding, like if I want to do a full welding to this bolt, I gotta get somebody and pay them. Not that the pain is it's no problem, because at the end of the day everybody got put food on the plate. The thing is, it is annoying. It's a small thing, you had an opportunity to learn, you ignored, and now you are paying the price. Yeah, there is no harm in having knowledge and knowing many things, and let me leave it at that. You have your say, man, and let us engage one another and talk to each other. We will meet in our next video. Have yourself a wonderful day.